So with this lecture, well, with this session, we're going to look at how we created a platformer game using UDK. So most of this stuff is really going to be on a programmer orientated. So how many of us guys here are programmers or have done programming? Handful of guys here, great. But you know, when you use UDK, it's not really just about the programming side of things, right? It's a collaboration with everyone. You've got to be able to, you know, mix in the art stuff as well, and that's what really makes a great game. Okay, and so one of the things with that mixing is that we have level-specific gameplay, and we use kismet and matinee to control that. And that's because you want your level designers to have the power to decide what kind of level gameplay elements they want. So if they want, you know, because it's a platforming game, you're going to have you know, platforms that slide in and out and move up and down, and you want them to decide exactly how that's done. And we're going to touch on a concept today called archetypes. And a brief description of them is that archetypes are really configurable objects, and you use them for really quick iteration of gameplay objects. Archetypes is a topic that doesn't often get discussed in UDK, but it's a really, really powerful feature that I think a lot of people are missing out on because they don't use it. Okay, so we're going to have a look at we're going to actually have a look at some of the code and actually break down what UDK is doing under the hood, so that you get a sort of a framework of, okay, so this is what UDK does when it starts up the game. A lot of programmers, when they first start using UDK, they sort of start looking for where is the main loop? Where is sort of that loop where the game starts executing stuff, and how, you know, how does it know which level to jump into when it first starts the game, that sort of thing. So one of the first constructs it does is that it creates an object called the GameInfo. And basically the GameInfo handles the game type, you know, what kind of game is this, and it handles all the rules of the game. So as you're playing the game, you know, the GameInfo checks for things like, has the timer run out for the level, has the player run out of lives, and things like that. It also handles spawning or the creation of the player controller for the player. And I'll touch base on what the player controller is very soon. It also handles spawning of the default pawn for the player, for the player controller to possess and to use. And the pawn is sort of like the physical representation of players inside a game. So the dude running around shooting guns and stuff like that, that's a pawn, basically. And it also handles giving all the default inventory to all the players as well. So when a player is here and he spawns into the world and the player controller possesses that pawn, the game goes, oh, here you go, here's a couple of guns for you to start, you know, running around and start shooting with. Or you can decide, you know, give him some keys or give him some books or whatever. It doesn't really matter. So we're going to have a look at the player controller and what that is. So controllers are actors in the game, and they control other actors. And the reason for this is that it provides a common interface for the AI and players to use. So say, for example, you have an avatar, the physical representation of an actor. You have an upper sort of construct that can be either a player or an AI, and then they sort of tell that pawn what to do, for example. So that way, you know, you only have to code things once. You don't have to code a pawn which has its own AI that can do its own stuff, and then you have another pawn which is for the player. You don't need, you know, so basically this is a sort of a construct to say you don't repeat yourself, sort of thing. And so what player controllers do is that they act as the bridge between the input from the player and the game world. So as the player controller receives input from, say, the keyboard, mouse, or gamepad, and it interprets those values into something meaningful into the world. So when you press the up key, you know, it tells the pawn that it's possessing, you know, move with the velocity in the direction that you're facing, for example. So with that in mind, we've got two classes in our head now, the GameInfo and the player controller. So let's have a little look at those two classes. I'm just going to bring them up onto the projector. I'm actually going to put them up on that side so you guys can still see what's happening in the slides here. And I'm just going to go back to the GameInfo slide. Can everyone see that okay? Even at the back, you can see the text, or should I make the text bigger? A little bit bigger? A little bit bigger? Okay. That's good? Sweet. Okay, so let's talk about the GameInfo and let's map this to the code of what's happening. So we know that the GameInfo handles the rules of the game. And as we peek through the code, we don't really have a lot of rules for the platforming game because really what it is just the player is running around, moving around, shooting stuff. I didn't, for the platformer, for this particular session, I didn't implement things like a timer run out or a lives maximum. But if you were to do that, you would do it in here. So now I didn't talk about the second point here, which is that it handles the spawning of the player control because UDK already has code that handles that for you. You don't need to worry about that. So the thing about UDK is that it's actually a complete game engine. It's not like just a renderer, for example. Because it's a complete solution, it handles quite a few things for you. But what it does do is that it handles spawning for the default pawn, and we can override that. And we've done that here using this function here, which we called spawn default pawn for. And we've got which controller we want to spawn for, and at which navigation point we want to spawn at. And from here, we basically just check if we have an archetype, which is an instance of a pawn. And as we go through it, you're getting lots of little bits of information, but as we get closer towards the end of the session, it'll all start to tie together. So basically, we spawn here. We spawn the archetype of that pawn at a start spot's location, and also at a start rotation. And then we return the object that was spawned. So that's almost about as much as you need to know about the GameInfo. And we also do have another function here which just gives some default inventory. And in this case, it's looking for an object that's built into the map. So just keep a note of that. And it looks through an array of stuff, and basically anything in that array, it just passes that to the player. So just keep that in the back of your head, that we'll come back to that, and you'll see how that starts to all piece together. So we're going to have a look at the player controller. Right, so it looks like I have to adjust the fonts. Right, so this is the player controller, and as we recall, the player controller controls other actors, and it provides it acts as the bridge from the input to what this pawn should be doing. And so we have this function here where it's called player move, and here it interprets the player input and what we want to do with that input. So because we want to make a side-scrolling game, we only really care about the left and right keys, for example. And the left and right keys are actually mapped to this variable here. And again, UDK sorts this out for you, so you don't actually need to worry too much about that. But in an advanced, in a later stage, you can decide to say, well, I want to remap the keys so it's slightly different. You can do that, but we're not going to touch on that in this session. So because we want to make a side-scrolling game, we need to actually calculate the vectors in which direction to move. So if the camera is pointing towards me, you want to find the X direction, which is towards me, and you want to find the Y directions, which is out that way. And if we produce a velocity based on those directions, that's how we create the side-scrolling effect. So what we do here is that we grab the camera viewpoint. And again, a lot of this code has been written by the Epic guys. So I didn't have to magically just write this code from nowhere. So I just used a lot of the functions that they made. So I grab the camera, and I get its viewpoint, its camera location, its camera rotation. I then grab the axis out of that rotation. So if the rotation is like that, and I grab the axis, I grab the X axis, which is in this direction. I grab the y-axis, which is in this direction. And I grab the z, which is up and down. And and because it's a side scroller, I only really care about the x and y, or in this case, the y, which is a side scrolling effect. And basically, this is just fluff for like making sure that we set the acceleration for the pawn and stuff like that, and that produces the movement. So one of the common questions is, how do we get the game to actually use this player controller? And how we do that is by linking up the GameInfo and telling the GameInfo to use that particular player controller. And you can see there's a definition down here that we want the default player controller class when we're using this GameInfo to be using this player controller. And that's one of the first steps when you make your first game, is to define your own player controller, define your own GameInfo for the game to use. Okay. So with all of that in your head, we're going to move on to the HUD. So the HUD is the heads-up display, and that displays information to the player. So things like health, crosshairs, perhaps how much mana the player has, or his current ability and skills, those sorts of things. And again, we're going to touch on archetypes here again. With archetypes, because you can create these objects inside the editor, it allows you to store values, and you can tweak and mess around with those values at runtime. And that allows you to quickly iterate over things. And we're going to touch on that now, so let's have a look at the code. So this is basically what an archetype in code looks like. As you can see here, all I've got is a class definition, which defines the object itself. And all I have next is a bunch of variables. And then I have default properties, and there's nothing in the default properties. So basically all it is that it's a data class. It just contains data. It doesn't have anything else in it. Oops. So from that, here is the HUD class, and this is in this HUD class for this platformer game, we actually just draw a crosshair so that the player knows exactly where he's shooting from. And one of the things that I do is here I pre-cache the size of the cursor so that I don't have to recalculate the size of the cursor each and every frame. And then I have an event. Now, events in UnrealScript are functions that the engine calls. So basically, each time this HUD is being rendered, it calls this function UnrealScript. And that's basically a hook to allow you to do your own things. And that's usually the way UDK is built up. It has the engine level code, which then calls other code inside script files. And they basically provide you with hooks to do things. And so in this post-render function, I check if I have a HUD properties object reference, and that references to that previous class that I was talking about, the HUD properties. And basically all I want to do here is draw a crosshair that sort of demonstrates where the player is shooting from. So I use a little bit of vector mathematics. So basically I grab where the weapon is right now, and I shoot like a vector that goes outwards, and depending on the rotation of how the player is looking, I then calculate the position of that vector in world space. And from there, you can see that here, so the weapon start location, the weapon aim direction. So I grab those variables out. I then grab the cursor position, which is the world location of where the cursor should be, and then I use a canvas projection function, and that basically converts a world position into screen space. So that's, again, another function that's been pre-built by Epic, so you don't need to write that code yourself. And then I just draw the crosshair using these sets of functions here. Now the best thing that you can do later on today is actually you can download all of the source code from the UDN, and it's in the development kit gems. And so when you download that information, it's fully commented as well, so you can check out what's happening at each and every step. And that way you can sort of take what you are learning in this session today and sort of fit the other pieces together as well. But just know that in the HUD, all I'm doing is drawing a crosshair in front of the player's gun. Okay, so we'll just continue forward. So the next thing we want to change is the camera as well, because traditionally when it comes to Unreal Engine games, we think like, oh yeah, you can make a first-person shooter. They did that with Unreal Tournament 3, and you think like, oh yeah, you can make a Gears of War clone, like a third-person shoulder camera, but you can actually do a lot of things with the camera. So cameras basically just control the viewpoint at which players see from. And camera is just another actor, basically. And it just exists somewhere in the world. It has a location, it has a rotation. And based on that location and rotation, it then says, this is where the player should be looking from. And again, you can actually create data classes, which you can then archetype. And these will allow you to quickly iterate over how the camera behaves. And we'll see that very soon. But we'll just take a peek at the code. So again, I have a camera properties class. And as you can see here, it's very simplistic. All it has is some data. So all it has is a camera offset. And basically, all I want to do with that camera is, it's a vector. So if the camera position is here, I have a camera offset which can push it out in the X and Y, the X direction, which is this way, or the Y direction, which is this way, or the Z direction. So if I enter some values, it'll just adjust where the camera is in the world. So we'll then check out the camera class to figure out what that's doing. Okay, so we've got some more hooks here. So update view target is basically a hook that allows you to update where the camera should be looking from. And all basically I do here is I output the location of the camera. And the location is determined by the target actor that the camera is currently looking at. And that's typically, traditionally, the player. And it's the pawn class of that player. So we start with that location there. We then add the camera offset, which is defined in our camera properties class. So that, so say the pawn is here, and you apply a camera offset, so it sort of is up here somewhere. And then we rotate the camera towards, so that faces towards that actor. So what we're doing here is that we have a pawn here, we apply an offset somewhere, and then we say, but look towards that player. And that's basically what we're doing. And that's a really simple camera. And this kind of camera code basically allows you to create a top-down camera, because if the offset is just up here and the camera is just looking down here, you've got a top-down game. You can create a side-scrolling game by just moving the camera out towards that direction, and the camera will automatically look in that direction. And because we've defined the camera rotation as always looking at the player, if you remember in the player controller, we look at the rotation of that camera to define the movement. So I'll just jump back to the player controller and you sort of see what I mean. So in the player controller here, we grab the camera viewpoint. And because the camera viewpoint, in this case, is looking straight at the avatar, you've got an X and Y direction, which is the avatars here, X and Y from there, and then you've got the Y going that direction, and the Z going up and down. And because the camera rotation is directly looking at it, if you press left or right, you'll get this kind of movement. And that's what produces the side-scrolling movement. Okay, so we're going to have a look at pawns and what they are. So pawns are actors that controllers can possess and control. So basically, when a player controller receives some input, it processes that, and then it feeds that into the pawn that it's currently controlling. And so pawns are the physical representations of players. And the other reason why we also wanted to do that as well is so that you can create a game where you can jump between different pawns, if you like. So it's sort of like you're sort of mind-jacking between different players, for example, different pawns. So you can have like 3 robots, and the player can control any one of those 3 at any given time by jumping between different ones. And so it allows you to give some game mechanics that way as well. And pawns themselves, they handle all the physical stuff. So they handle collisions, they do sounds, they do animation, and all of those things in that class. And again, the reason why you want to have it in this one class is so that when you have AI, you don't need to rewrite all of that code in the AI class. You just say, you, pawn, player sound, sort of thing. So if you sort of think like the player controller is like the king of that pawn, it makes a lot more sense, because then you're just saying, you, minion, do this, sort of thing. And you can archetype those pawns. So you can create variations of the same class and just assign it different meshes or assign it a different material. Okay, so we're going to have a look at weapons, and we're going to have a look at how they interact with the world. But actually, before we do that, let's have a look at the pawn class, the code for it. So it's a little bit bigger, but I'm going to go through just the most important parts of it. So we don't need to really worry too much about these variables here. Just know that it handles things like the turn rate of how fast a player decides to turn. But it also has things like a jump height, how high he can jump up and down. And it has some other miscellaneous bits and pieces as well. But really what it's doing, what most of this code is doing, is just doing things like animation, when it should play sort of like a recoil animation when the player fires his gun and things like that. So some of the parts that can link back to the previous things is these two functions here. Get weapon start trace location. Now we needed this function inside the HUD because we need to know where the player is going to start firing his weapon from, right? Because otherwise we don't know where to trace out from to produce the crosshair position. So by doing it this way, by asking the pawn class, where are you firing from, it gives you a much more data-driven method. Rather than having a hard-coded value, if the player is controlling, say, a car, you can say that, oh, he's firing from the turret, which is at the top, defined by like a thing at the top. But if the player is controlling just a human being, you can say, oh, he's actually firing from a gun that he's holding in his hands, for example. So it gives you a really nice, flexible system for doing things. And we've also got a aim, which was used in the HUD as well. I'll show you where it's used in the HUD. So here we're asking the pawn, it's get fire start trace location, and it's aim. So basically the HUD is relying on this data feedback from the pawn. And you can basically feed it whatever you want, and it'll just continue to act as if, okay, it doesn't really matter where you're firing from, I'll just calculate accordingly. So we'll peek a little bit more into the pawn. That's not it. And basically we can define other things like when the pawn takes damage, what it should be doing. In this case, I've just called the super take damage, and that's basically saying that this pawn class subclass is the default one that comes from UDK. So I don't really want to change. I didn't decide to change any behavior, so I just said, just do the current behavior that it's doing. And basically, I have all this other fluff code here, which we don't need to really worry too much about. So we're going to have a look at the weapons. And so weapon provides players one way of interacting with the game world, because you can shoot stuff, you can blow stuff up, you can kill other pawns, that sort of thing. And again, we're going to use archetypes to further allow content designers to actually design some of the gameplay. And basically, with archetypes and with all of those things that I've been talking, cameras can have archetypes, pawns can have archetypes. The reason why we do that is because we want to create a data-driven system. We don't want to hard-code things in our code, because we want to let everybody on the team have a chance to be able to create the game as well. So I'll show you a little bit of the weapon code and what that's doing. And again, a lot of the code for the weapon comes from UDK itself. So UDK itself handles things like ammo. It handles things like the weapon is not ready yet to fire. It handles things like, okay, so the weapon is now being equipped by the player and it's not ready yet. So it does a lot of stuff for you. So once again, it's really about finding the appropriate hooks that exists in the UDK code and going from there. So this is the weapon code. And what I've decided for the platformer was that every weapon was going to shoot projectiles. So all I have here is a projectile fire stub, function which came from UDK itself. So UDK itself defined this function, and I've just overridden it. And all I've done here is, I've asked the instigator to play the sound. The instigator is the person that fires the gun. So the pawn owns the gun that he's carrying, and so so the weapon says, okay, the pawn that's carrying me is the instigator. I then ask the pawn to play the recoil, so that every time he fires the gun, he does some sort of recoil. And basically here, every time the weapon is being fired, he spawns a projectile in the direction. And again here, you can see the classes here being used again. Get weapon, start trace location, get adjusted aim. So the weapon code is, again, looking inside the pawn and saying, like, where should I start firing from, and in what direction should I be firing from? Okay, so we're going to have a look at the platformer game, so you can sort of start to see how all of this is piecing together with a visual representation. And after that, we'll move on to the simple enemy AI. Okay, so this is a really simple side-scrolling map that I've made. So I've got lots of detail along one axis, but I haven't made a lot of details across the other axis, and that's really because the other axis doesn't matter at all. So we're going to start the game, and I'll just turn on guard mode so I don't get killed. So you can see here we've got the HUD, and it's drawing the crosshair. And where the player fires from is at the very tip. Is at the very tip of that weapon from. And then we cast, so that's the direction that the player is firing from. And so because we start there and we've got the aim direction, that's where the crosshair is going. And because we've got the camera out here, and it's facing towards the player, when I press the left and right keys, that's the direction in which he moves in, because inside the player controller is where I'm controlling that from. Just turn this quickly. Just turn that down. So as you can see, all of these pieces are starting to fit together because now we've got a pawn, we've got the player controller, which is me with the inputs, the keyboard and the mouse. We've got the HUD drawing the crosshair. So we're going to have a look at a couple of the properties in the map, and we're going to reference that back to the GameInfo and back to the map properties that I was talking about earlier with the default inventory. Okay, so in UDK, we have the world properties. And that defines for us a couple of things. So in the game type, as you can see here, I've selected this particular GameInfo, and that was the GameInfo that we were looking at just before. So UDK, when it starts this map, it'll load this GameInfo, and then when the GameInfo starts, it then goes, okay, so which player controller do I want to use for the player? And so it looks at this default property here, and so it says, okay, I'm supposed to start this player controller. And then from there, the game goes, okay, so now that I've spawned the player controller, which pawn do I want to give the player? And so it executes this function here, spawn default pawn. So what we do here is we spawn an archetype, which is defined in the default properties as well. But we give the player a default pawn that we want through this function. And then after that, after it's given the pawn, it then says, okay, we need to give something to the player. We need to give him some default inventory. So it executes this function here, add default inventory. It then checks for this data class. And as you recall, this, so this data class located here has an array of weapon archetypes. And it basically goes through this array and it spawns each weapon archetype and it gives that to the player. So as I go through here, it loads the MapInfo, which was that class before, and it goes through the archetype, iterates through it, and it tells the inventory manager, which is owned by the player, to create some inventory for it. And how that hooks up with Unreal Editor is that in Unreal Editor, if we go to the world info, we have this map info, and we have a weapon loadout here. And that basically demonstrates a really, it's a data-driven method of, so that a level designer can make a new level and he can say that, okay, when the player starts this level, he should start with a rocket launcher, or he should start with a link gun, or he should start with this. And it basically, the programmer doesn't need to worry. He just says, I've created a data-driven system for you. You can decide to do whatever you want. And that's really nice. It really allows for really quick iteration times, and you really don't have to worry about things like, you know, the level designer doesn't have to go to a programmer, oh, hey, I want to do this level and I want to do this specific thing, because the programmer can just say, well, that's no problem. I've already created the data-driven system for you. So that's how all the pieces are starting to fit together. So let's have a look at some simple enemy AI. So early on, I told you a sort of a white lie, kind of, that you always needed a pawn and that you always needed a controller. So if you wanted to create any sort of AI, you need those two actors. The actual truth is that you don't actually always need this sort of situation. Because the thing is that pawns themselves are physical representations of stuff in the world, right? They're like the character that's holding the gun. But even within this, they can set their own velocities. They can sort of do some really simple logic to decide what to do. So you can actually remove the whole controller out of the whole thing. And again, we're going to use archetypes here, as it makes it easier to tweak how the AI is going to behave. And it also you can also customize the appearance. And we're going to start looking into archetypes real soon. So I actually talked about the custom map info already. And we're going to jump now to the custom kismet stuff. But before I do that, I might start showing you the archetypes and what I actually meant by that. You know, it allows content designers to start messing around with the game design. So I'm actually just going to change this game into a top-down shooter, and I'm not going to don't have to recompile the code. And that's because in my archetypes that I use, if we go back to the camera properties, if you remember the properties inside there, inside that class, it was just a camera offset, right? So I'll just open that class up again. Which one is it? Yeah, so in the camera properties archetype, all we have is a camera offset. And in the archetype that's stored in the inside our packages, we've defined a camera offset of -42 in the X direction, so it's sort of poking out from the player's perspective, and we just lifted the camera up a little bit higher. I'll just write those values down so I can restore them later on. And so the really nice thing is that you can actually modify these variables while the game is running. And that allows you to really do extremely quick iterations. Oops, here we go. Right. So we can go, okay, let's bring the camera up a bit higher because we want to make a top-down shooter. And we don't really need to pull the camera out because we want a top-down shooter, right? So we can reset that back down to 0. And we can bring that up a bit again, and now we've got a top-down shooter. And this is really why you want to use archetypes, because I didn't have to recompile code. I can change the camera while the game is running. And as you know, I can play with this view for a while and be like, I don't really like it. I really want a bit more of a slant. So you can say, okay, let's add a few values here, and you can produce a value, and once you're done, you can actually just then save the package, and you're done. So I can exit from this game. I can stop it running now, and I can save the package that I've got. And so now that I've made those changes, I can replay the game, and my values have stayed the same. And this is really why you want to use archetypes. It frees up the programmer from having to continuously rewrite these values in script and having to recompile every single time a small, tiny change needs to be made. But you can also actually go one up from there as well. You can also allow content designers to change and to modify exactly how characters start to look like. So we were talking earlier about a pawn archetype, and here we've actually got a player pawn archetype that I've defined here. And in the properties, I've got things like the turn rate, I've got things like the jump height, I've got things like a flag mesh and how much health the player has. So I can actually tweak all these values, resave the package, and it'll be working inside the game. So I'm actually going to change what the character looks like. So he was like some human dude before. So I'm actually going to change him into a robot. So I can check out what current mesh I'm using by clicking that, and it comes up here. Okay, so I'm using this person over here. So that's kind of what he looks like. But I'm going to change him over to a cyborg because I've decided, as a game designer, I've decided, no, humans are boring. Let's make it cyborgs instead. So all I need to do is find the appropriate mesh that I want. So I want a cyborg dude, which and this guy will probably fit the bill. So I then can I select that in the content browser and I can plug it into there. So it's now using the robot dude. I can then save the package, and then I can restart the game and see what that looks like. So he's now the robot dude rather than the human dude. So what you can do this, the reason why you want to also do this is so that when you set up the code once, you don't care what kind of mesh this thing is. Because at the beginning of your game, when you first start making it, everything could be cubes, right? And you don't really want to have the art designers fully dependent on programmers just to change what the guy looks like. You want the art designers to be able to go into editor, open up the archetype and just go, oh, I finished making the cyborg skeleton mesh, and I just want to hook it up. And this allows you to do it without having to recompile the code. Okay, so that's kind of cool. You can change a couple of values, but you can't really design a game where all you're doing is just changing a couple of values. So, so the next thing we're going to do is we're going to go another step further. We're going to actually start making a new weapon using just archetypes. So I'm going to show you what the current weapon sort of looks like. So he's just shooting some kind of like the link gun, which is some sort of energy weapon like this, right? And you go, okay, we want to make him have a rocket launcher instead. So we can go into our weapon archetypes, and I have a link gun weapon. And if I expand it, you can sort of see you can mess around with any of these values. You can change what sound it plays. You can change how fast it fires. You can change its spread, and so on. But we're going to change its projectile class because we want to turn it into a rocket launcher instead. So using this drop-down box, we are allowed to select a couple of classes here. And I'm going to set it to the rocket class. And again, in this case, I've just chosen classes, but you can actually make these archetypes as well. So you can make an archetype of the projectile you want to spawn, so that way you can even create new projectiles inside Unreal Editor. So I've selected now to the rockets. And I'm just going to save that, and I can start the game again. So I've actually created a new weapon here. This is really interesting. Yeah, well, it'd be chainsaws and not rockets, but well, if it was a rapid-fire chain. But that's really the power of archetypes, and that's why you want to use it. It's all about rapid prototype development. And I haven't even compiled the code once. Well, I compiled it initially right at the start, but after writing it, compiled it once, when I make these changes, I don't have to recompile over and over and over again. So we're going to jump over to the simple enemy AI now, and we're going to have a look at some of that. Oh, actually, sorry. We're going to have a look at the custom kismet. So in this case, with the custom kismet that I've got, it actually allows the level designers to introduce new gameplay without me having to do a lot of work. And most of the time, the nodes are really simple. And certain types of gameplay elements are just better to be created in Kismet rather than being created using UnrealScript. So I'll show you the custom Kismet. So basically, all I've got in this Kismet is that I basically tell the enemy AI who I should be shooting at. So basically, all I've got here is a hook that Kismet calls. It calls a function called activated when Kismet decides that this node should do something now. And all I do here basically is assign AI with a target. And this code really isn't that important. All you have to know is that this code tells some AI to start shooting at this other thing. And because once you see it being used inside Unreal Editor, that's where it really starts to make more sense. So going to the Unreal Editor, oh, sorry, we don't do that. And we open up Kismet, you can sort of see how it's being used. Okay, so we've got our custom Kismet here, which is the set instigator. And basically what we've got here is that for each along the way, we've got these really simplistic AI robots that will just start shooting at things when you tell it to set, when you've set an instigator. So what I have set up is I have a trigger here. So those are the triggers there. And again, this is a class that exists inside UDK, so you don't have to remake these or make these from scratch. And this Kismet says if the player or if something touches this trigger here, then this event gets called. And the instigator is the pawn that touched this trigger. So it feeds that out into this object variable here, right? And from here, this branch here then calls this Kismet node, which is the set instigator. So I've set the target to the platformer turret, which is this guy here. So if I right click and if I say select in level, it's somewhere else. So it's this guy here. So basically, I'm telling the target to set the instigator to whoever touched this trigger. So that way, in multiplayer games, if another player touches that trigger, the bot is going to go, oh, you're now my instigator that touched my trigger, so I'm going to start shooting at you. And so basically, this allows level designers to decide when and where these turrets should be activated. Because, I mean, the programmer has no clue. The turrets could be up in the ceiling, they could be embedded in the wall, they could be under the player, and sometimes you want the trigger to be somewhere else. So sometimes what you want to do is, as the player, you might have like a really cool cinematic scene where the player is running across a hallway, and he's just touching lots of triggers along the hallway, and that in itself triggers some matinee to open up some doors, and like lots of turrets are starting to shoot at the player as he's running through a hallway scene. So these kind of setups, it's really easy to create in Kismet, as long as your programmer says, I'm going to do it this way, because then that gives you the opportunity to make the gameplay rather than me having to script everything inside UnrealScript. So we can sort of see that in action. So what I'm going to do is I'm going to step through and debug the Kismet so that you can see exactly what's happening at each step of the way. So I'm going to set a breakpoint here. This is one of the newest features in UDK, by the way, is the ability to debug your Kismet sections. So now that I've set a breakpoint in that Kismet, I can sort of see what's happening with the game. Okay. And I'll turn on Kismet debugging. So when I start the game, okay, so I've started the game. I'll move the player. And you can see here, Kismet has already triggered the breakpoint because I've touched that trigger. So activation count is 1. It then says, okay, this is now being active. So I'll step through. So I'll run to the next action. So it then toggles and turns on the turret. And it also calls the set instigator with who touched this. And it tells you who touched this. And so that turret now will start firing at me. And I'll just step through. And I just want to continue on. So as you can see, the turret guy is now shooting at me. So that's basically an overview of how I created the platformer game. I used a lot of archetypes so that I could be really flexible. Initially, I actually wanted to create a top-down game, but I decided, no, a platformer seems to be what everybody wants in the forums. That's sort of like the first, when UDK first came out, a lot of people were asking, how do I make a platformer game? Because that seemed to be popular at the time. And so I decided to change this into a platformer game. And using archetypes, it was really easy. I just had to input a couple of values. I didn't need to do much changes to the code. I also had no clue what kind of weapons I wanted. So by making archetypes of the weapons, it allowed me to decide, to play around with several values and then go like, okay, the link gun is probably the best kind of weapon to demonstrate. But if I wanted to, I could change it into a rocket launcher. By archetyping all the pawns and stuff like that, it gave me the flexibility of saying like, well, I'll set it to this guy for now, and set it to the human guy for his appearance. But if I really didn't like how he looked, I could just say, well, I'll just change it later on, like I did here. All right. So we're coming to the end of the presentation. So basically, how many of you guys have actually downloaded UDK and started using that at the moment? Okay, so basically everyone. Yeah. So one of the things, if you ever need help with UDK, Epic Game Forums has a subforum, and that's basically dedicated to UDK. There are actually a lot of veterans who use UDK and use Unreal Engine 3. And basically we do our best to help everybody out. So usually I check the forums a couple of times a day, and I try to answer questions as much as I can. And the website for that is, I think it's supposed to be forums with an S, .epicgames.com, but yeah. And you also have access to the UDN, the Unreal Developers Network, and it's dedicated to the documentation of Unreal development kits. So I've really, really quickly gone through a lot of UnrealScript, a lot of the features with things like archetypes and how skeletal meshes and all that sort of stuff. I've gone through them really, really quickly, but the documentation on here goes through some of those things really, really much more elaborately. So you get a lot more information out of the UDN. And we try to update it as often as we can every month. And we have new materials, reference materials, tutorials, examples. You can actually find the platformer example on the UDN through the development kit gems. And we try to add new development kit gems every month. And that's located at http udn.epicgames.com. Okay, well that's the end of my presentation. If you have any questions about this lesson specifically, feel free to walk up to one of the microphones and ask the question. If nobody has any more questions, I will probably just elaborate on some of the other points here that I've gone over a little bit too quickly. So I'll just wait a couple of minutes if anybody wants to ask questions.
Yeah, so I noticed when the enemy turret was shooting at you, it went by on the side of the main pound, the character pound.
Mm-hmm.
So we have to program also for the turret to attack on a vector, so it always goes in the same direction, not in the against the other axis.
Yeah, I probably went through the enemy AI stuff a little bit too quickly. So let's have a peek at the code which controls the turret. So again, I have a bunch of properties here which can all be modified using archetypes. Basically lots and lots and lots of variables. And when it comes to the firing part, so the firing part gets set when if we remember in Kismet, we first toggle that turret to be on, right? So we first activate the pawn. We first activate the turret using this function here. So Kismet toggles, so I'll show that in the Kismet so that you can see it. So when that trigger gets touched, it toggles that turret, right? So when this Kismet actually gets executed, it runs this function here, which then activates the turret, and it calls that function activate. So it calls this function here. So it plays back an animation sequence, and when that animation sequence finishes, it then starts. It calls this function here on animation end or on anim end. We then set a timer for its firing. So basically, what that is basically in a certain amount of time, run this function, and you can set that to looping, which is what I've done here, true. So every fire interval, it'll call this function called fire timer. So what I've done here with the fire timer is basically I've looked for a socket location on the weapon of the guy, and using that socket, it returns a location and a rotation at which I should be firing at. So what I've done here is I've actually depended on the socket's rotation and location rather than actually calculating a variable. And I'll show you what I mean and what a socket is. So a socket is located on a skeletal mesh. And as you can see here, we have several sockets on this guy. And I can point to any one of those sockets, and it will give me a location in world space, and it will also give me a rotation as well. So what was probably happening with the turret guy, if we run the game again, we'll probably see what was happening. So what's happening is that the socket is somewhere near the front of the gun. I'm just going to move slowly, hopefully I don't get too much feedback. So the socket is here, and the socket has a rotation of like there. So I'm relying on the data of that socket to return the rotation for me, rather than calculating, oh, he should be shooting towards that direction. I mean, I could do that if I wanted to, but then your projectile will probably... Can we just turn that off?